connection. I'm at a atypical place, so I'm hopeful that my connection is good. And then the other thing is, because I'm doing it remote from where I normally do it. Everything I loaded up was from the MCAT Boy account, not my regular email account. And I'll go ahead and see if a couple other people. I think this might be it. And let's see. Oh, the person who submitted questions is not actually here yet. So I'll show what the questions are, but if they're not here, I'll open it up to other random things. But everything was from OChem StereoChem lecture. And the questions dealt with just basically structural, like what stereoisomers preferred. That's what this one is. What happens with optical rotation? No, nobody. I did all the WMC yesterday. So yeah, I just basically powered it. And it's kind of weird because the AMC, there's one person from this session from your class, and then two people from last session who were just, I guess, just way ahead of it, because the fact that they're asking for 3 and 4 is just kind of weird and out of sync. And I have a feeling there'll be a lull, and then you'll start seeing more WMC kicking in and mid-December. Yeah, it was 4. It definitely saw last Wednesday, I think it was, and then yeah, yesterday was 3 and some 2. But I think they're actually doing it in flipped around order. I think they've just decided not to do 1, 2, 3, 4 for whatever reason. So every now and then there's some craziness posted at Reddit that people catch on to and think, hey, that's genius, I'll do it that way. And the reality is you just got to learn from it. It's a bad call to do WMC and do sample tests first and then do some other tests to get used to the timing, so that by the time you get to the 4 good WMC ones, you know what you're doing. I don't think it matters what order. So I'm of the mindset that the only thing that matters is that you do their sample test first, because again, for anybody who's done the sample test, did you learn a little bit about how they ask questions? So who was caught off guard? Like, whoa, these questions are, number one, a little more straightforward, but also just different, weirder than what you've been used to. Or not more straightforward, but easier concepts. You just had to connect more things together. And I think it's that shock value is definitely a major part of doing their WMC exams. Yeah, and then that's the other thing. So for anybody who's taken the MCAT before, did the real ones seem similar but not exactly like WMC practice? Was it WMC? So which one seemed harder to you, the real one or the WMC practice tests? Yeah, and there's a reason for that, and I never like to put this in writing because I know it'll come back to bite me in the butt, but it's always been that way with WMC, because how much does it cost for a practice test? How much does it cost for the real test? So the real test is what, 300 and something right now? And if their practice test is so hard that it talks you out of taking the real test, they end up losing money. So I'm of the mindset that they make their full-length practice test just a little bit easier than what you'll expect on the real thing. And you're doing it to get, I mean, the score is still a good predictor. It's still a decent predictor what you get if you took that test. But they are, the real test you should expect to be a little bit harder. The passages and cars and psych to be a little bit longer. The bio questions to be a little more analysis needed. The chem physics to be a little more applied. But again, and this is what I love, you guys don't mind sharing your experiences with each other. So, and how many just feel, I don't know, just a sense of relief when you realize you're not the only one who felt that shell shocked from the real one? Yeah, and the difference that, at least from my personal experience, what I found, the one new version of the MCAT that I took, what I found was it had so much crap in the passage beyond what I was expecting, like tables and graphs, and there was just so much buried in it. And it was doable, but it wasn't as straightforward as I thought it was going to be based on the practice exams. I had to dig a little bit more. And I don't know if you felt that way as well, or anybody felt that way, but it's just, I felt reassured when other people said that. Yeah. Okay, so I will go ahead and start into the 3 questions and then just open it up. If you want to load things in the chat box, we can also do it that way. But for this one, so let me go ahead and get this up and screened up. Okay, so without knowing reaction 2, I'm actually going to do this without reaction 2, and then I'll go backwards and say what it was. But do you recognize this functional group? So a 3-membered ring with an O in it, it's formerly known as an oxyurane if you're IUPAC, but also known as an epoxide, like somebody just said. Yep, so it's stable or unstable, that 3-membered ring. So oxyurane or epoxide, doesn't matter what you call it, but highly unstable. So it's a great intermediate product. You form it on the way and then you attack it later. But the way it forms is you oxidize an alkene. So basically this comes there, that goes there, and you end up with either that or, so it's got to go from the same side because O is being added at one time. So just as a general rule, this is physically impossible. You cannot, if you think about what that would take, if I have one bond up and one bond O down, can that O be the same O as there? So can I have an O that's connected above and below? Yeah, it's called, yeah, let me write the word out, but yeah, the generic name is epoxide. The IUPAC name is oxyrane or oxyrane. And I never understood what the difference is spelling. Somebody explained that we have British and standard spellings, but at any rate, I think this is the standard IUPAC and this is also accepted, but epoxide is a generic term for it. But I can eliminate these 2 choices because you can't have one bond up, one bond down because the O can't be in front and back simultaneously because they're both connected to the same atom. It's got to be in front or back. Steric hindrance wise, what do you expect to have happen? So this group right here, is that going to create some steric hindrance on the front or back side of the original molecule? Front. So where's the O going to have an easier time attacking? From in front and possibly run into this, or in back? In back. So what do you predict then? Yeah, perfect. So it's just a little bit easier to come in from the back side. Perfect. So it's going to come in, it's going to go in the back to be away or opposite side. Yeah, I know, Brooke, you totally had the right answer, said everything. So I'm just, was it just asleep at the wheel sort of thing, or just you totally knew the right answer, just happened to say the wrong one? Yeah. And those are the little things. So actually, as you get closer and closer to test date, anytime you do that, I want you to stop and be cognizant of how that happened. And honestly, on test day, I seriously think you won't run into that as often because adrenaline is higher, focus is better, just everything. Okay, so next question. Which following explanations does not account for an observed optical rotation greater than that of a positive literature value for the pure species? What the heck does that mean? So the literature value is known as an alpha D. So let's just say it equaled 50, just to toss a number out there. What does that mean for the literature value? Is it a optical rotation or is it known as a specific rotation? So I'm going to put another equation up here and tell me if this looks all familiar. The absorbance of light equals, actually, let me put the constant first. E, some molar absorptivity constant, L, and C. How many have definitely seen this equation before? It's known as Beer's law. Okay, so Beer's law says how much it absorbs depends on a property of the material itself, E, how much you have, and how long the pathway is. So if the absorbance of light depends on how much you have in the path length, do you think the rotation of light also depends on how much you have in the pathway? Would that also make sense? How much it absorbs, the more it travels through, the more it's going to absorb. The more it travels through, the more it's going to rotate. The more you have, the more it's going to absorb. The more you have, the more it's going to rotate. So would it be reasonable to assume that rotation could depend on those 2 as well? So to ensure that we have a standard value, we have standard conditions. So 1 gram of material dissolved into 100 milliliters of solvent, that's the standard concentration used, and the 1 decimeter length, so that you have an exact distance it goes through. So let's go one by one. If both enantiomers are present in unequal amount, what the heck does that mean? What would that do? So what exactly does that mean both are present? So let's first consider, what does it mean if you had 50% of one enantiomer and 50% of another? What would you get? Racemic mixture, perfect. 0 degrees, no rotation. So what if instead you had 60-40? Then you would get some positive number, but you agree it wouldn't be that large, because 40 would be canceled out, 40% would cancel out 40% there. So it would be positive, but you agree the positive literature value is for 100%. So which is going to have a higher rotation, 100% of the plus or 60-40? 100%. Okay, so this one, this is looking like the answer for now. I don't think that's going to work out. Okay, the solution is too concentrated. So again, if I put more in there, is that going to create more absorbance? Is it going to create more rotation? Is it going to create more of every single interaction with light? Sure. The more stuff you have, the more of everything. So just, if you don't believe that, how many have ever made like Kool-Aid or Crystal Light or one of those powdered drinks you toss in? The more powder you put in, the darker it gets, the more it absorbs light. So whatever it might be, you're going to get more rotation. The polarimeter, the device you're using, is too long. Is that also going to be true? If you have a longer path, you absorb more light. So if you have a longer path, you're going to absorb or rotate more light. And then last but not least, the wavelength of light used is greater. So finally the third value here. What is that value? I got to actually pay more attention to that one now. That value is the absorbance at a very specific wavelength. For whatever reason, I don't know why, but that letter there has nothing to do with rotation. It has to do with using a sodium lamp, which has a 589 nanometer wavelength. So if we think about absorbance, and it's my best correlation, how many would agree graphs sometimes look something like this? Like, would that be an absorbance graph that would seem reasonable, that you could potentially see? Sure. So do I get a different absorbance depending on what wavelength I use? If I chose any of these 5, would it be a different absorbance? What are the odds rotation is similar? So whatever I know for absorbance, would it make sense that one wavelength might rotate more than another or less? So let's say my sodium lamp was here, but if I used a different wavelength, is it possible to have even more absorbance? Or if sodium lamp is there, would it be possible to have even more rotation? Perfect. So therefore, what's the best answer? When you mix enantiomers, it makes it closer to 0. So kind of a cool question in the sense, how many see the correlation between Beer's law, the absorbance of light, and rotation of light? How many can actually agree that, oh, that makes sense? If it's absorbing it and these things matter, then if it's rotating it, these same things probably matter. The wavelength you use, concentration, and the path. And the power of something like this, how many are noticing you can actually do that a lot? You may not know exactly what's going on in one question, but if you know another topic really well and they're similar, you can take what you know in one and apply it to this new situation. I mean, is that something you've noticed yourself getting better and better at? Making analogies, taking something you know and making analogies to something you don't know, or vice versa. Hopefully that's going well. I'm going to click on then. Which 3-dimensional conformation corresponds to 3-hydroxy cis decalant? So this is what's really weird is you have to put the H's in. So I'm going to go ahead and put the H's in at the bridge. So this is the bridge here. So up and down, because at every point up, axial up, point down, axial down, point up, axial up, point down, point up, point down, point up, point down, point up. So I learned that trick from my wife, who just has that awesome way of doing chair conformations. The way the point goes, that's the way you put your axial. So in this case, based on the structure, would you agree the two H's are cis or trans? Ooh, okay, perfect. Yeah, trans. One up, one down. So that's out and that's out because trans. And I need cis. Okay, so this one's right. Sorry, H and then H. Those are both are considered up H's, up H, up H. So this OH here should be cis or trans. It is so wonky looking. Got to be cis. So again, I'm going to draw this line. Are they on the same side or different side in choice B? Same side, so therefore they are cis. Opposite sides, trans. So if I went cis, I need that one. Would they ever make you do that? Translate from a two-dimensional structure into a three-dimensional? Oh, definitely draw the H's out. It's so much easier on this one. Yeah. And I don't know, I mean, if it's worth drawing chairs all the time, but I think this is that rare case where it might help just because sugars show up on the MCAT. And knowing chair for the sake of cyclohexane on the MCAT, yeah, it might help. Knowing chair for the sake of sugars definitely will help. So I didn't stick around for the end of Isabel's lecture, but did she, like, just based on the note she put out, looked like she went in and just revisited sugars a little bit? Oh yeah, I guess I'm assuming she was crunched for time because she loaded a lot in that lecture. But she, yeah, and I gotta admit, she ended up being the star it looked like she would be. She was the one I held the most hope for, and she just totally rose to the occasion. She was freaking awesome. So that was really really nice that worked out well. Anyway, hopefully you felt the same way, her awesomeness. Yeah, and she gives a shit. She spent so much time putting a quality lecture together. So see, fab, I'm assuming with all the extra B's means that's a good thing, right? If it would have been one, maybe two B's, that's not as good, but the third B really solidifies it. Okay, good. Because I'm an old guy. I don't understand this young person hip language. But 3 B's, I'm assuming, is awesome. Okay. Anything you guys want to load in the chat box for me to put up? Because that was it for what was submitted into the MCAT poll. If you send them into the other email, I'm so sorry that I'm stranded and I didn't get back in time. I had my interview today, which I was happy with. Yeah, so oh, structural isomers. Yeah. I think it went okay. I write poorly, and I tried writing on a pad while walking around. That was a miserable failure. Okay, but somebody asked, quick trick for counting number of isomers. Oh, how many despise these questions? So for stereoisomers, yeah, it's basically 2 to the number of stereocenters. Yeah, doing that wrong. Number of stereocenters squared minus meso. That's the easy one if they give me that. But if it's just all, like, how many isomers for, let's say, a C6 alkane, then I just have to do, yep, they're such a pain. You have to just systematically say there's only one long chain. Okay, so that you always get one for the longest chain. So what's shorter than 5 or 6? That kind of gave it away. And so I actually choose a different color for doing the next one. So that seems okay. That seems okay. So let me keep drawing. How about that one? Yes or no? Yeah, the question is, if I want to count up how many isomers, is there a way to do it? And unfortunately, it's just being really systematic. That's the only approach to these things. There's no formula. So unique, or is this one the same as this one? If in doubt, name it. 1, 2, 3, 4, 5, 6 in a row. This is linear hexane. 1, 2, 3, 4, 5, 6 in a row, linear hexane. Okay, that was out. What about this one? This one's unique, I think. So I have 2-methyl pentane, 3-methyl pentane, 4-methyl pentane. Do you agree that works too, or did I mess that one up? What's wrong with that one? Numbering from the other side. Hey, speaking of numbering, Jonathan, the trick you did in office hours, it was so awesome. How come you held out on everybody in the lecture? I was a message, private messaging Isabel saying, Jonathan's method's great. Ask him. He's great, and whatever. And then you totally held out on me. You went pre-med on everybody. Oh my gosh, it's a genius method what you did. Oh yeah, he did explain it eventually, but only after coaxing and peer pressure. So anyway, but yeah, your method was genius. And so just wanted to point that out. Oh, you're welcome. Thanks for having it be a genius method. And how many definitely agree it's nice to be able to do things in a systematic, shortcut way every now and then. Okay, so basically start with the chain length. Longest chain, that's 1. That's my freebie. 5 in a row. On 2, on 3. If I go here, that's repeating 2. If I go at the end, that's repeating this one. 4 in a row. Can I have 2, 2? Check. Can I have 2, 3? Can I go 3, 3? Nope, because 3, 3 is nothing more than 2, 2 backwards. Can't go 1, 1 because that's one of these. So here's going to be my guiding light then. Make the longest chain, make the next longest chain, and only put them on the middle, never on the end. So when you branch on the second one, the third one, if it's symmetric, never branch on the end ones, branch both on 2, 2 and 3, can't both be on 3. So I think that's going to be the best advice I can give, is just get really systematic. So is it okay if I move up to C7 and see if we can get really fast? Is that okay? Because we're doing this, none of you will have this on your MCAT. The people who didn't show up for office hours, they're going to have like 10 of these, even in cars. And how many are just totally aware that MCAT knows exactly what you study? Longest chain, that's my freebie. Oh, we all need good karma. Okay, never on the end, always on the middle. So there's my 2 and my 3. Why am I not putting it here? Same, perfect. So I can have it on the 2, on the 3. If I put it here and called it before, it's really the 3. If I put it here, same as that one. So what's the next longest chain after 6? 5. And so again, what I can do, I can have 2, 2, 2, 3, 2, 4. Shoot. I'm at my palette. I'm so sorry. This is bad planning on my part. And then I can also have 3, 3. Perfect. So like you said, 3, 3, exactly. So it can have 2, 2, 2, 3, 2, 4, and 3, 3. So now I'm up to 4, 5, 6, 7. And then if I can have one that's 4 carbons, that's 3 attached. There's my 8. So I wish I'd give you an answer that's some nice, easy shortcut, but basically, is it just being really organized? Is that the secret to these? Now being pragmatic, on the MCAT, do you think they'll give you C27 and ask you how many? Or do you think they're only going to go up to C4, 5, 6? Yes, yeah, evil one. It wouldn't make sense for them to go much beyond 7. Also, the one thing that I want to just chime in and say, nomenclature, they give you a lot more pictures. So for people who take the MCAT, would you agree they draw a lot more structures and they really don't demand a lot of nomenclature? Yeah, I mean, they were so good about having compound 1, compound 2, compound 3, and drawing the structures out, as opposed to making you do names. I have done maybe a disservice because I put probably more nomenclature in the book than what the MCAT will give, but it's just for the practice for the 1 and 2 nomenclatures. But do not be low. Don't be pulled into that misconception. There's a lot of nomenclature. The book has a little bit too much. Okay, now you want to talk about stereo centers? By all means. So do we have any stereo centers on this one? I'm going to say that's a stereo center. You're going to say right on or no? Todd's going to lie. You bet. It's been so long since I've had class. I haven't been able to lie as much as normal. What about this one? Chiral center? Sure. So that looks like 1. What about this one? Nope. So apparently, can you only get chiral centers when you have something on 3? Or could that potentially be chiral? I love being tricky. Can't be because those two are identical. CH3, 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 CH3. Todd's gonna lie. Okay, so that didn't work out too well. So what about 6th one? 7th one? Chiral center there or no? Nope. Either of those? Nope. So as it works out, we only have this one. Oh shoot, didn't mean to do that, didn't do that. This one to worry about. That might be a somewhat reasonable question. So that's not beyond their realm, but hopefully it seems okay. So sorry, the answer wasn't, oh, I got this cool formula, I can get everything right instantly. You still have to systematically go through it. But is this a little bit easier? At least when you know it's systematic, you know you can do it by a countdown, 7, 6, 5, 4. Why am I not going to do a 3 carbon chain, by the way? Longest chain has to always be half or more of the compound. So in other words, if I have 7 carbons, I can't have a 3 longest chain because there's no way I can stuff them all in the middle carbons. You're going to eventually have a longer chain. Okay, again, anything you want to load up in chat or ask away, now is that perfect time. Oh, you're very welcome. And honest feedback from you guys, how many are not yeah, oh, a section bank question, sure. And let me just warn everybody. So somebody wants to ask a section bank question. I think if it's okay with you guys, section banks and Q packs, and then flashcards, I will never give a warning. I don't care if I ruin those because there's no score. You're not sitting down and doing them under time conditions. If you are, I will try to give a warning. And then, yeah, the other thing, how many are just fried on things, and how many at this point, and this feedback will help me a lot. How many find actually cutting the questions and loading them into a email to say the ones you want to go over, is that becoming a pain in the butt? Would it be easier just to type the question you want? Is that the limiting factor for anybody, just making the screenshot of the question? Or is that like a 15, 20-second ordeal and no big deal? Yeah, so I mean, I can try to find the balance on that. Yeah, and the one thing that helps, somebody in Discord asked if I could please give warning if it's a double MC, and I feel horrible because I can't give warning because I don't know till an hour beforehand what people are going to submit. And so yesterday it was a game time decision. I honestly thought, I told the oh yeah, for that one, okay, thank you. From that, the earliest, sometimes it's June 4th, June 10th, whatever day. When you submit, your application is just going to sit in limbo until the data people start entering stuff in. But it's a first come, first serve approach. So if you submit on the first day, 2 or 3, even though they're not going to verify your application for a week or two, it still gets sent to schools, and some schools will send out a secondary even for your unverified application. So one of the biggest advantages you can have is to start really early. So in other words, have your application ready to go. So if you take your MCAT, not a bad idea to start putting together who you're going to ask for letters if you haven't asked already. Personal statement, start thinking about it, and more than anything, get a theme. Like, what is, if you can say one word that's the most important thing to being a good doctor, take that one word, whatever you think it is, and then go backwards, and all the things that you think have influenced your choice to become a doctor, how do they tie to that one word? So let's say you choose compassion or communication, intelligence, whatever that one word is. What in your pathway to become a doctor ties in? Because how many of you ever noticed if you have a theme, things flow so much better? And so that's going to be a major part of the workshop, is just how to turn a boring application into one that they'll at least maybe look at a little bit more. And then the other thing is how to decide what the most noticeable things. You get to pick 3 of your most important post-secondary experiences, and those end up number 1, 2, and 3 with more characters to write about. Those become essential. Picking the right 3, the 3 that'll best represent you, becomes key. Okay, so back to this one. So I think we're pretty square on everything. I might end up just then pulling the plug until I can get home, and then jump to my schedule, and I'll play tag with you. So I'm actually right now at where I interviewed on borrowed internet. Okay, yeah, I'll jump into Discord as well then. Okay, well, thanks. I mean, again, thank you guys for always just the positivity. Sorry for the roundabout on all the that dang biotin one. Okay, well, thank you guys, and I will probably then just tap out then. So have an absolutely wonderful evening, and I will see you guys tomorrow for tomorrow's sound. So hopefully that'll be a good one. But I'm glad to hear. So has Koi gotten nicer? Oh, okay. Yeah, it's a mood swing thing. So Yeah, I think that I kind of agree with that. That was always the complaint about him in Berkeley, was that he would snap at people from time to time. But I mean, some lectures are definitely better than others for him. And I know circuits I thought was one of the ones he did well at. Wait, today was circuits. So what do you have left? You have sound and light and optics, right? Okay, light and optics is the one I'm really looking forward to doing, because that is one, quite honestly. Oh, I'm covering lenses tomorrow. I'm covering, yeah, next week. Yeah, next Tuesday should be lenses. That's one I really hope everybody comes to mind. As much as I know Coy can do a pretty good job on circuits and like the forces and translational motion. The his I really hope people come to the lenses I'm doing. That actually is going to be a better lecture. So anyway, all right. Well, I'm going to log off, and I will check in when I'm probably 40 to 50 minutes if traffic gods are kind. So if they're not, maybe an hour. So I'll check when as soon as I get home. All right. Thanks again, Jonathan.